Hello class, for this part 4, we're going to look at the conservation of energy, otherwise known as how energy is converted to one form to another in calculations. Alright, so just to remind you again how energy is converted, here I have a skater here, and if I lift the skater up a certain height, this skater has gravitational potential energy. So you can see this from this bar graph here. It shows the kinetic potential, thermal energy, and the total energy. So if I raise her up, you can see her gravitational potential energy increases, right? And if I let her go at a certain height, what's going to happen? Her gravitational potential energy will then be changed to kinetic energy. Why kinetic energy? Because she is moving once I release her from this height. So let's see that happening. Okay, ignore thermal energy for the time being. And you can see this is how the energy is changed. Right? So when she's at the top, she has a lot of gravitational potential energy, but as she reaches towards the bottom, her kinetic energy increases, and in fact, the kinetic energy is the greatest when she is closest to the ground. And then when she is at the ground, all the energy then becomes zero. Okay? But throughout this process, the total, as you can see, the total energy between these two are the same, remains the same throughout this process here. During calculations, remembering the fact that the total amount of energy would always be constant is very useful. So let's try this. Example 6, a flower pot of mass 2 kilograms is dropped from a height of 20 meters. What are the energy changes that are taking place? You have a flower pot. I'll just draw a circle to show that's a flower pot. And it has a mass of 2 kilograms. And it's being dropped from a height of 20 meters. So what are the energy changes taking place? So before, it has gravitational, and then that gravitational potential energy changes to kinetic energy as this flower pot begins to fall down, right? And then B, what is the speed of the flower pot just before it hits the ground? Now, this is where principle of conservation of energy takes into place. We know that all of the gravitational potential energy that is inside the flower pot, and when the flower pot reaches the ground, all of that energy is converted into kinetic energy. So we can say the gravitational potential energy, all of that is converted to the kinetic energy of the flower pot just before it hits the ground. So it hasn't hit the ground yet, it's just before that. We can use the formula that we learned last time. So for gravitational potential energy, this is equal to mgh, and for kinetic energy, this is equal to half mv squared, and we're trying to find the speed, the velocity in this case. Now let's put in the values into the formula. What's the mass of the flower pot? That's 2 kilograms. What's g, the gravitational field strength? We're going to take that as 10 because this is on Earth. What about the height? The height is given to us, which is 20 meters. And then we're going to fill in the right side of the formula as well. It's half times m, which is a mass 2, times v squared, and v is the variable that we want to find. I'll continue this on the left side here. 2 times 10 times 20, that is equal to 400. Half times 2, that is equal to 1 v squared. So the formula, the equation becomes this. You then try to find the square root of 400 in order to find v. Square root of 400 is 20, and the answer is 20 meters per second. Another example, the example reads, how high vertically would a stone of mass 0.5 kilogram reach if we throw it with an initial speed of 3 meters per second? So I'm going to draw a hand here, a very ugly looking hand. And this hand's going to throw up a stone of mass 0.5 kg with a speed of 3 meters per second. And so this stone is gonna reach a maximum height and then it will come back down like that. Okay. When we throw this stone, we are giving it, so before we are giving it kinetic energy, and then as this stone reaches the maximum height, all that kinetic energy is converted into gravitational potential energy. So that's after. So the kinetic energy is equal to gravitational potential energy when the stone is at the highest point. So how high vertically at its highest point. And then it's just a matter of putting in the equations. So for kinetic energy is half mv squared. For gravitational potential energy is mgh. And then you put in all the values that you know. The mass is 0.5. The velocity is 3. And then mass of the stone after is still the same. G is 10. And we want to find h. Half times 0.5 times 3 square is equal to 2.25, and then 0.5 times 10, that is 5 times h, and then you move the 5 to the other side, and therefore h is equal to 0.45 meters, right? And that's the answer. So example 8, I'm going to skip this part first because I want to talk about example 9, and that example 9 is a bit easier to understand. So in example 9, a skater is moving along a smooth U-ramp. Describe the energy changes within the system in terms of potential energy and kinetic energy. So in order to answer example 9, I have here this simulation here, this skater again, and then I have this U-ramp, and I want you to see what's happening in terms of the kinetic potential and the total energy between these two. So in the beginning, when she's at the top, she has the maximum gravitational potential energy. Okay, so I'm gonna let it go, and then you're gonna see what's gonna happen. I'm gonna turn on the speed as well so that you can see. Right, so when she's at the top, her speed is actually very low. It's in fact at the top, her speed is 0. She has 0 kinetic energy, but she has a lot of gravitational potential energy. But then as she goes down, her speed increases and that gravitational potential energy changes into kinetic energy. At the very bottom, she doesn't have the gravitational potential energy because all that gravitational potential energy changes to kinetic energies. And at the very bottom, her speed is the greatest. Why is her speed the greatest at the bottom? Because at the bottom, that's where she has a lot of kinetic energy. And as you know, kinetic energy, if you have a lot of kinetic energy, you will tend to have a higher velocity or higher speed. Okay, so that's what's happening. That's the energy changes as she is moving up and down on this U-ramp here. Another important thing to note is that the total energy remains the same, right? Even though these two energies are changing from kinetic to gravitational potential energy. Of course, in real life, this is not going to happen. In real life, there is friction, and friction is going to slow her down. And when that happens, she'll eventually slow down and then stop at one point. Let me show you that example. So this is in the case where there is friction. Right? So she will slowly slow down. And then because of friction, when there's friction, you are producing heat, just like when you are rubbing your hands. So all that energy is lost as heat. So let's see that again. Okay, so thermal energy increases because most of that energy change is lost as heat because of friction. And then she stops. So let's answer this question here. Describe the energy changes within the system in terms of potential energy and kinetic energy. When she has the top, she has maximum gravitational potential energy. When she's at the bottom, she has minimum gravitational potential energy or 0 gravitational potential energy. And then when she's at the top again on this side, she has maximum gravitational potential energy. Now, why does the gravitational potential energy changes from one spot to the other? That's because that energy is converted into kinetic energy. So when she's at the top, her speed is actually 0. That's when her kinetic energy is at the minimum or 0. So whenever she's at the top, the kinetic energy is 0 or at the minimum value. And when she's at the very bottom, that's when the kinetic energy is at maximum. Okay, because that's where all the gravitational potential energy gets converted into kinetic energy. And at the bottom, that's where she is the fastest. So at which point is the skater moving with the greatest speed? So this is at point B, at the bottom point. This is because the kinetic energy is largest at this point. A larger kinetic energy means faster speed. And then the second question, at which point is it safe for the skater to try out a flip or any dangerous moves? And this is point A and C, because this is when the skater is at its slowest, when her speed is 0, and the speed is 0 because the skater has minimum kinetic energy. Now that we have gone through example 9, let's go back to example 8. We can finally answer this. So the diagram below shows the football being kicked into the air. So at which point A, B, C, D would the ball be slowest? So you need to understand what's going on between the gravitational potential energy and the kinetic energy in this case. Let's think about that for a moment. So when the guy here kicked the ball at A, so the ball has just been kicked, this is when the ball is the fastest because it's just being kicked. It has a lot of kinetic energy. And then when the ball reaches at a certain height, which is C, this is when there is a lot of gravitational potential energy because this is when the ball is the highest. And then when the ball falls back to D, the gravitational potential energy is 0 or at minimum because this is where the ball is on the ground or has 0 height. So at point C, it has maximum gravitational potential energy. So the kinetic energy should be the opposite. The kinetic energy should be minimum or 0. And then back at D, so the ball, it has 0 gravitational potential energy. So all that energy is converted into kinetic energy. So that's when the kinetic energy is the maximum. It will look something like this. So when at the ground, its gravitational potential energy is minimum, but the kinetic energy is maximum. And then when at the maximum height, gravitational potential energy is maximum, but its kinetic energy is at minimum. So at which point A, B, C, D would the ball be slowest? It is at point C because there is 0 kinetic energy there. All that kinetic energy is converted into gravitational potential energy. Where would you have the maximum gravitational potential energy in this diagram? It is at C because it is the highest point. All right, so to summarize part 4, we looked at how you calculate energy when they convert one form to another. We especially looked at the gravitational potential energy and the kinetic energy in this case. So just make sure you remember that when it is high, the gravitational potential energy is maximum, but the kinetic energy is at minimum. But whenever it is low, the kinetic energy is the one that's at maximum, and the gravitational potential energy is at minimum. Next lesson, which is part 5, we're going to look at something that's called power.